Welcome to another episode of Answer Your Question. This is an episode in which I try to answer your question. You can post them down below or to an email to me. Alright, today's question is, how do I wire up a universal encoder module so that I can get simulated outputs? You realize this is a coding program and not a hardware setup program. Well, yes, we can still do this. So today, we're going to be talking about this module. And this module is called the SI-Uni Encoder module. You can see that there's 2 ports on it, and there's a little green plug that plugs in and out of it. It allows for 2 encoder inputs, or possibly 3 in special situations. We'll talk about those later. We're also going to talk about this cable here. It's called the ycable. It's probably set up a little bit different than you might think, so stick around for that. And also, of course, this little breakout board. Everyone seems to already know about it, but we're going to just briefly mention it. I know this video is about setting up the module to do simulated output, but more than likely you're going to also want to use this module as an encoder input. And if that's the case, it is good to look at this table. What this table is going to show you is the combinations that will work with the simulated output. Let's look at the table in some detail. So this first column shows you position feedback interface number 1. As you can see, there's AB servo, FD servo, and several other options in position feedback interface number 1. In the next column, P2, this is for position feedback interface number 2. You can see that it has many of the same options, but you're also seeing that there's these gray squares here. I'll get to that in a second. Again, the same story with encoder simulated output. There are some black squares with occasional word full or no Z marker pulse output. When you look at the table like this, when you have an AB servo encoder or any of these other options, then you can't use P2 or simulated output. And the reason for that is these particular feedback devices take up all of the pins on the module, so there's nothing free. However, if you have one of these type of encoders, like an AB quadrature encoder, well, that's only got an A0, B0, and a Z pulse, no commutation channels, well, you got half the pins still left open on the port, and the module's smart enough to use this for other stuff. So what can we do? Well, with this particular combination, we can use it for another AB encoder. So we could bring in 2 AB encoders, or in the case of this video, we could use it as a simulated output and get full A0, B0, and Z pulse output of the simulated encoder. With this option, you can have a P1 and a P2 device, but no simulated output. With this option, you can have a P1 with no P2, but you get a simulated output again. This time, you don't get the Z pulses. However, this particular combination of encoders allow you to use P1, P2, and a simulated output. So now your question is how do I actually wire it? And we're about to get to that. Let's break down how this table works. The column over here on the left talks about the 15-way D-type connector. This is a female plug, and it has, of course, 15 pins. And what it does is it has 2 encoder ports built into it. One of them is called P1 and one's called P2, as we talked about. So we have this other plug called the 10 pin. And you might think, well, this is for P2 and the 15 is for P1. That's not how it works. You'll notice that this section right here, you can see that pin 7 and pin 3 are lined up, and pin 8 and pin 4 are lined up, and pin 9 and pin 5 are lined up, and so forth. These are technically hooked together between the 2 terminals. They are exactly the same. So you can wire into pin 7 of the 15 or pin 3 of the 10-way. It means exactly the same thing. Up here at the top is the breakdown of all the protocols that the encoder supports. Let's do an example of how this table works. Let's say we want to use an AB servo. Well, if we look down the column, you're going to see that it uses all of these wires. You're going to have on A would use pin 1, on A0 that's pin 2, on B that's pin 3, and on B0 that's pin 4, and so on all the way down. all right? And so you would definitely going to use the 15 pin because you can see the 10 pin does not go all the way up here. Let's do an AB encoder. Now an AB encoder only needs to use A naught, B naught, and you could use Z and Z naught. And also you'll have these inputs down here as well. But with that said, it left this section of terminals free to use either on the 15 pin connector or on the 10 pin connector. Now if you look closely at the description, it says P2 and encoder simulated. That's because it can be a P2 or a simulated output. If you look back at the first table we looked at, you can see that when you have an AB encoder, you can either have it with a P2 input or you can have it with a full simulated output, but not both. Well, now let's get to this special case. How do we actually do this one? Well, this is how it looks. You would have the indat of P1 would use 1, 2, 3, 4 on pin 15. And of course, it would also use 13, 14, and 15 on 15 because, of course, you need power. And then P2 would use pin 5 and 6 and 11 and 7. And the simulated output would use either 7, 8, 9, and 10 of the 15. Or better yet, you could use the 10-way pluggable connector because it's easier to wire and use 3, 4, 5, and 6. Now you're going to say, wait a minute, this says P2 encoder sim out. How do I know that this was supposed to be for the simulated and not this? Well, that's a good question. That is why there's 2 more diagrams that you need to look at when you're doing with simulated outputs. And here they are. And if we look at this bottom one here, it talks about when we're using an indat with another indat, that this is how it's set up. If we go back, we can easily see that P1 is this section. But P2, how does that work? Well, it says P2 is wired to connection 5, 6, 11, and 12. And the simulated output is 7, 8, 9, 10. Now this table also shows that the encoder simulated output has more options than just A and B, which is a standard incremental quadrature encoder. It can do frequency direction output, it can do frequency in reverse, and it can also do SSI. As you can see, this module does quite a bit, but we're not quite done yet. There's a couple accessories and how to use them that we haven't discussed. As you know by now, you can wire up a motor like this using the standard cable. You also know by now that you can add a second motor like this, but you have to break the cable and use the 10-way port. Or you can use the 10-way port as a simulated output. Or you can buy this thing that's a breakout board and wire it however you'd like. The last thing we need to discuss is this thing called the ycable and how it works. Now, a lot of individuals think that it's just a splitter cable, and it's not. If it was a splitter cable, you couldn't hook up 2 motors just like this, exactly the same, and plug it in. So this is what they've done. So you can see over here that the yellow dots are how the first motor is wired up, and the second motor is wired up using the green dots. Well, you can see they're exactly the same except for the thermistor. So what they've done is they've crossed these inputs over to pins 7, 8, 9, and 10 so that the rest of the pins are used. If you'd like, you can remove this motor and hook a breakout board to B2, but you still need to be aware that this is how this splitter cable works. Thanks for watching another episode of Clean Code. If you're still bored, feel free to check one of these other videos out. And if you want, please subscribe.